Hello student, here we started the most important lectures on thermodynamics. We already covered the basic concept of regarding the thermodynamics and thermal equilibrium, and then we complete the Joule law of thermodynamics. So in these lectures we study about some thermodynamic systems, what are the types of thermodynamic system, and last one we complete what is meant by internal energy. So before start today's lecture on thermodynamics, I just introduce myself. My name is Manohar Patil and I am the founder of Rise Academy, the coaching institution that is present in our Shirpur. So you can join the coaching class for your mathematics and physics preparations for the state board as well as examination like the CET. Okay, so let's start. So the today's we have to study about what is meant by thermodynamic system. Before that, we just revised the all three concepts we already complete into the previous lectures. So first, that is thermodynamic system. What is meant by thermodynamics? Thermodynamics is the basic. There is the study of heat and temperature. After that, we complete the thermal equilibrium. What is meant by thermal equilibrium? So thermal equilibrium is a very simple concept. So it means when two objects or the systems having temperature is same, so we can say that both are in thermal equilibrium. And after that, what is the Joule's law? Simple statement given by him. He considered the three bodies A, B, C, and the body A is in thermal equilibrium with C and the body B is in thermal equilibrium with C. So definitely we can say that the body B is thermal equilibrium with C. So it is very simple observation. If two objects or the bodies or the systems are in thermal equilibrium with third, then both must be in thermal equilibrium. So this is the law of Joule's law of thermodynamics. And after that, we just start what is meant by thermodynamic system. So let's here remember now it's very easy for understanding the thermodynamic system. Thermodynamic system means the ability of any object to exchange the energy with surrounding. So if you look at now we observe that so many objects, now this is the pen is there. If the temperature we hit the pen, so after hitting the pen, if the temperature of pen is maximum as compared to surrounding, so what happen in that case? The delta T is set up, there is no zero. That means delta T is not equal to 0. When the delta T is not equal to 0, so definitely heat transfer also not equal to 0. So heat transfer take place, and remember that how the heat transfer take place, it is at maximum temperature with surrounding. So heat transfer take place from that pane to the surrounding. So here pane loses the energy. Now he exchange the energy with surrounding. So what happened? The pane is thermodynamic system. So remember the very basic concept of thermodynamic system. So the object or group of objects having ability to exchange, having ability to exchange energy, or we can say that heat with surrounding is called thermodynamic system. Very simple definition. Any object having ability to exchange the energy with the surrounding. Let's our body is the best example. So when we take the two example in the winter session, what happen? We go outside. Our body temperature is very high. That is high as compared to the surrounding. So our body exchange the energy that is lost. In summer, what happen? You are going outside in time of the 2 p.m. Heat is large in the outside, your body is less temperature, so your body taking the heat. So in that case your body absorb the heat from the surrounding. So in both cases your body's exchange heat with its surrounding. So depends on the temperature is higher. When the temperature is higher, it definitely loss. When the temperature is low, definitely gain just by the natural convection. So here, after the thermodynamic system, if we consider that this is the thermodynamic system, So remember, for the study of thermodynamics, you understood the three important concepts. First one is the system. You clearly understood any body having ability to exchange energy with its surrounding. And next, after understanding the concept of thermodynamic system, the next definition you have to remember, that is surrounding. It is also called environment. So what is meant by surrounding? Surrounding, it is very easy. The part of the universe other than system, it is called surrounding. The part of the universe other than system is called surrounding, or it is also called environment. So this is the system and this is the surrounding. And remember, the system and who separate the system and surrounding, that is called boundary. So remember the three important words. First one is thermodynamic system. We already complete. The ability of the any object to exchange the energy with the surrounding, it is called thermodynamic system. The part of the universe other than the system, it is called surrounding. And who separate both, that is the boundary. The boundary is the reason, the layer which separate the system and surrounding. So after that, so the system, thermodynamic systems are divided into the three categories. First is open system. There are the three types. Second one is closed system. And the last one is isolated system. So these are the three types and the most important types. So let's we start one by one. So when we study about the open system, just we go by the example. So here we take the example, we heat the water. And when we heat the water, and after heating the water, and now the temperature of water reach up to the 100 degrees centigrade just off the burner. So what happen in that case, wherever we heat the water and the temperature of that water is up to the 100 degrees centigrade, so after that our observation is, so now the water vapors are start and going up, and after the sometimes we observe that so temperature of water going to be reduced, it may be 80, it may be 30 degrees centigrade up to, so when the temperature of water is going to be decreases and now the vapors are going into the space, into the surroundings, so what is the observation, so we can say that now here the energy and matter, so matter means that is the vapors. So energy and matter both are exchanged with the surrounding. Both are exchanged with surrounding. So here hot water is the system and the complete space is the surrounding. And now very interesting simple question, very observation is very interesting. Heat the water and just stay for some time. So now the temperature of that water become decreases. So when the temperature decreases, definitely so heat is transferred by that hot water to the surrounding. So here exchange of energy, as well as when it is converted into the vapors, they are going into the environment, so that is the mass also goes out. So some amount of mass of that liquid is going into the gases form, so we can say that also exchange the matter. So very simple definition of open system. Remember what is the definition? They exchange both energy and matter with surrounding. Next we take the same example. Again we heat the water up to the 100 degree centigrade, and whenever we heat the water up to the 100 degree centigrade and its gas burner is off, just put the plate over that pot. So whenever you put the plate over the pot, after the some time you observe that the temperature of that hot water becomes decreases, but those vapors they are developed due to the at the higher temperature, they are not going into the space, they are not going into the environment. Why? Because it is closed structure. So here we can observe that After some time, the temperature of that water is reduced. So here only exchange of energy with surrounding. So there is no exchange of matter, so only exchange of energy with surrounding. And the next example, that is the isolated system. We everyone know that thermos is the best example. So when we carry the hot tea for the long times, for the long distance, so it becomes hot after that time. So what is the meaning of that? Thermos is the material, and the property of that material, remember that there is interesting property of that material. Having property is which do not transmit the energy from one to another. So we can say that thermos, it is the material having thermal conductivity is very very less. So thermal conductivity of the thermos material is very very less. So therefore it cannot transmit the heat from inside to outside. So there is no transfer of heat from inside to outside, and definitely it is the closed structure. So therefore if the water is there, hot water or hot tea, we take the example. So those are vapors convert, they are also into that space, they are not going outside, so matter is not going outside. And what about the energy, the temperature of that hot liquid or the tea inside that thermos, it is same after the some time. So we observe that there is no transfer of heat from inside to outside. So here the thermos is the material, it is selected because having thermal conductivity is very very less. Similar, we take the example of bricks. When we make the construction of our home into the India, we mostly the peoples are use the bricks. So why we use the bricks? Because having thermal conductivity is very very less, so it's protect in each environment cases, that is winter, summer, so and rainy season. So therefore it is most important. So remember that how here now we complete the all three observations. So very simple, we just take the revision very quick and very fast. First, thermodynamic system is the ability of any object to exchange the energy with surrounding. After that we complete the part of the universe other than system, it is called surrounding. Who separate both, that is boundary. How many types of the thermodynamic system? Open system, closed system and isolated system. What is meant by open system? Remember the example, hot the water, you make the water temperature 100 degrees centigrade and just as it is placed for the cooling. So when it's cool, so temperature of that water decreases, definitely transfer of heat from high temperature to the surrounding, because surrounding temperature is near equal to 30, 37 or like that 27. So and also the vapors are going into that space, so that is the surrounding. So here the energy and matter both exchange with surrounding. When we observe about closed system, same example, just plate is over there, so this is the complete closed structure. Though no matter is going outside, but after some time the temperature of that hot water inside the pot, it becomes decreases. So we can say that only exchange of energy with surrounding, not matter. And then we go for the isolated system. It is very simple. In isolated system, we take the example of thermos. Thermos having the property less thermal conductivity, so therefore heat transfer take place by this material is less. So remember the best example, air is the best bad conductor of heat because having thermal conductivity is very very less. So here what happened, it is an enclosed structure, closed structure, so therefore the vapors are not going outside. Next one, due to the thermos, energy also not lost, so temperature of that water, hot water or the tea inside the thermos as it is after some time. So these are the three important observation. So make the notes, read, revise, remember the example. Examples are very simple, many times they ask into the state board examination also. We go for the next topic, that is internal energy. Now it is very interesting. Remember the assumptions of kinetic theory of gases. There is the most important assumption of kinetic theory of gases, the all molecules are moving in random motion. So what is the meaning of that? The gas molecules are not follow the particular path, they are moving in random motion. If this is the, if you take the example of balloon and if you fracture that balloon, so the molecules, one is moving in this direction, next is this direction, next is this direction, next is this direction. So what is the meaning of that? The each molecules going in any direction, they choose their own path, they moving with the different velocities. The velocity is also not constant. Every molecule is moving with different velocity, so therefore we go for solving the average velocity. That is called also root mean square velocity. So here this is only important concept for study the internal energy. So remember that the assumptions of the kinetic theory of gases, the gas molecules are moving in random motion, that is disorder motion. So when the molecules are moving with random motion and the energy associated with that molecules, it is called internal energy. And also remember that the total energy of the atoms or the molecules of the substance, it is called internal energy. So remember the two definition or the two important points. First point is, now it is very easy to remember, the energy associated with random motion of an molecules is called internal energy. Is called internal energy. So remember here the most important word is, that is random motion. And next one, the total energy of a atom, total energy of atoms or molecules of the substance are called internal energy. So these are the two important observations. First is from the kinetic theory of gases assumptions, and second one is very simple, the total energy of atoms and the molecules, that is called, of the substance, it is called internal energy. So when we go for the some example, remember that for monoatomic gases, and next we go for the polyatomic gases, and last one observation for the liquid and solid. So here for the monoatomic gases, what is the internal energy? Remember that monoatomic gases having only 3 translation degree of freedom. So it has only translational kinetic energy. So the internal energy, so in case of for monoatomic gases, internal energy is nothing but translational kinetic energy only. Remember, this is the important word. And next, when we go for the polyatomic gases, so remember that the internal energy in case of polyatomic gases, so remember the example, that is carbon dioxide. So now the internal energy is nothing but the translational vibrational and rotational. So in case of polyatomic gases, internal energy is nothing but the translation kinetic energy, vibrational energy and rotational energy. But whenever we are going for study, these are the for the gases, but when there is the liquids and solid, internal energy also consists of potential energy, and that potential energy associated with the molecules due to the certain height, or it's just because of the force of attraction between the molecules of the substance, between the molecules of the substance. So these are the these are the 5 important points we have to remember. Now it's very easy. So first one is the energy associated with the random motion of the molecules is called internal energy. The total energy of the atoms or the molecules of the substance, it is called internal energy. When we go for the example of for monoatomic gases, the internal energy means the only translation kinetic energy, And for polyatomic gases, internal energy means all three energies, that is translational, vibrational and rotational energy. And last, when we go for the liquids and solid, there is also, other than kinetic energy, there is also consist of potential energy, and that potential energy is due to the force of attraction between the molecules. So now here we complete the both important topic. This is the internal energy, and before we complete the thermodynamic system. So just watch the videos, write down the notes, and remember and revise many times, multiple times, so you can understood the concept very well. Thank you very much.